brief on private sector participation in BOT project of Magong 5,500-ton desalination plant. Penghu County is an offshore island with poor natural conditions. The lack of natural water resources affects the sourcing of city water, resulting in livelihood water source deficiency, which causes inconvenience in the daily lives of Penghu residents. Penghu has a flat terrain that lacks rivers and mountains, and a climate model in which annual precipitation is far lower than the amount of total evaporation. Reservoirs have a small watershed and a short rainwater collection time. In a dry year that lacks plentiful rainfall, reservoirs run low with insufficient water storage, and water shortages are likely to occur. For a comprehensive development of offshore islands aiming to improve water quality for residents' daily use, as well as for corresponding to the increase of water demand resulting from tourism developments, it was a priority mission for the Taiwan Water Corporation to explore more water sources and expand city water facilities to provide an adequate supply of quality city water when the original facilities are at full capacity for both water production and water distribution. Desalination plants have become an emerging water resource, equally important to traditional water sources in many developed coastal countries, offering an effective solution to mitigate or eliminate the unbalanced supply and demand. In order to resolve the present insufficient water supply in the Penghu area, the Taiwan Water Corporation decided to build the BOT project of Magong 5,500 CMD desalination plant to stabilize the water supply by way of desalination, increasing the amount of clean water and capability to regulate the supply corresponding to quality fluctuations in the source water. Putting aside cost considerations, for enhancing throughput and water quality, Chinful Water Resource Company Limited, a participant of the project, selected one of the first-class desalination systems in the world, which included a UF filter as the pre-treatment of seawater desalination, thus offering a steady yield. This will stabilize the water supply in the Penghu area, providing a safety standby load and achieving smooth deployment of the source water in the area as well. Located at Magong City of Penghu County, the project covered both the Magong plant and Wangan plant. A new 5,500 CMD system was constructed at the Magong plant, together with the refurbishment of a 7,000 CMD system, totaling a production of over 10,000 tons of potable water a day. A 400 CMD system was refurbished at the Wangan plant, providing 400 tons a day. Since Penghu has special geological and climatic conditions, the project faced multiple challenges in its execution. The Penghu Islands, including the plant area, are comprised of a basalt formation that is hard and rigid. When excavating the foundation, there was only 1 to 2 meters of topsoil propped up by basalt underneath. The excavation was therefore mainly carried out by breakers in combination with power shovels. Since the plant area has a shallow seafront, working barges for laying the seawater piping were unable to approach the seashore. A cofferdam extending 250 meters into the outer sea had to be built so as to utilize the ebb tides 2 times a day, during which the seawater within the cofferdam was pumped out with pumps in order for the construction machines to carry out excavation on the seabed. By high tide, the machines were again withdrawn ashore, thus cycling the excavation work. The offshore location for laying the water intake structure was first excavated by excavating machines that were carried by a barge to the location. Then, the intake structure was carried by the barge from the wharf to the installation location, where it was connected to the water intake pipe, 1 meter in diameter and 320 meters in length, and sunk into the seabed. A brine water discharge pipe with a diameter of 900 millimeters and a length of 1,200 meters was laid extending offshore. All maritime works were carried out with protecting marine ecology the first priority, in order to minimize the damage to tidal flats and rocky reefs on the south side of the plant. The excavation work was kept to a minimum. To prevent the pipeline from being struck by wave breaks at the tidal flat, a duct was excavated to accommodate the pipeline. After laying the pipeline, the duct was grouted with high-strength concrete to protect the pipeline, followed by replacement of the surface sandstone originally excavated from the site, so as to restore the original terrain of the seashore. The pipeline underneath the tidal flat was anchored with concrete blocks to minimize disturbance to the seabed formation. A compact spatial design based on optimal land use provides a smooth and convenient process sequence, as well as flexible scalability in the future, making extensive use of existing facilities and natural terrain conditions for accomplishing the most economical desalination plant on Penghu Island. The project consists of the construction of a 5,500 CMD water intake pipeline, a brine water discharge pipe, a desalination and filter tank, UF equipment room, sedimentation and regulation tank, water intake wells, and a pump room. The refurbishment of the 7,000 CMD treatment plant included a first RO room and a second RO room, the addition of a 2-story operation building, and the refurbishment of a 400 CMD plant. The construction of a desalination plant requires effective integration of mechanical and electrical devices and water quality instruments, as well as graphic control systems to achieve stabilized operation of the desalination mechanism and reliable process units. During the construction period, professional teams with different specialties were united, and engineering quality was controlled via a comprehensive quality control program, so that construction tasks were engineered to the specified quality requirements. On completion of each unit, test runs were carried out to ensure that the specified quality of the desalinated water was achieved. The plant is therefore designed with a large number of local characteristics, such as reproduction of traditional tribal villages with external walls decorated with traditional gables. Since Penghu has limited sources of architecture materials, it is vital that a traditional structure use local materials. That is why Laogu stone, a wall decoration using local stones, dominates the architecture of the plant. To convey the collective characteristics of leisure, romance, and the dynamic energy of Penghu, sails made of perforated plastic board were used to reveal the image of the brave who stood tall against the seas. However, the streamlining was gentle and smooth, suggesting a spirit that blends rigidity with softness, which fully complies with the island characteristics of Penghu. Trees are arranged in open spaces within the plant. Bushes fill in the spaces. Ground-covering plants are further used to cover any exposed soil, forming a three-dimensional plantation comprising high, medium, and low vegetation layers. Not only blending the plant with natural ecology by providing a habitat for insects, birds, and small wildlife, but also creating scenic landscaping within the plant. The plant also acts as a model that functions as a location for education, leisure, and sightseeing activity. Effective and continuous recycling of water ensures sustained development of our society and economy.